Questions about the setup tomorrow? I didn't reveal too much because I don't think I need to. Yep, Emily? I will give you the formula sheet, which will have the quadratic formula on it, yes. Okay? And yes, I threw a little bonus on there. The bonus does involve similar triangles. It's not like a random hard math problem I found in a book. All right, it does involve similar triangles. Amy? Will there be a question that's like the distances of two triangles? No. If it's a dilation, if it's similar on the graph, no. No graphing questions tomorrow. Nope, I didn't put those on there. Anything else before I get to your quiz? Okay, probably going to go through this question by question. There's a couple questions we don't need to go over, but most of them we will. Okay, very first one. First problem number one. I told you the triangles were similar. Find x. So you had to match up the corresponding sides. So the first one I'll take is AB. That's 3x minus 2. Now, if you can't tell from the diagram, I also provided the similarity statement. So AB corresponds with DE, which is 2x. The other side in triangle ABC I know is 25. And AC corresponds with DC, which is 20. You solve for x, you get 4. Now I asked for the ratio of the corresponding sides, but if you looked in the directions, it said find the ratio of sides of ABC to DEC. So triangle ABC had to come first. So that's why you could have picked off 25 to 20, or some of you reduced it down to 5 to 4. If you did 4 to 5, I understand that. What I didn't understand is where a number other than 5 and 4 came from. That I did not pick up on why. Okay? I did not know that. I get if you did 4 to 5, you just didn't read the directions carefully, but anything else, I wasn't too sure where it came from. We all good there? I don't have to go over number 2, but I will just mention I got it off an old Regents question. So that's an old previous Regents question, number 2. Anything else on number 1 before I move on? Then you guys, there was another one down here I wanted to go over. 3, right? Yep, 3. And again, if you got these right, just stay with me, please. Are the triangles similar? Review time. Review time. 3 ways of proving triangles similar. Angle, angle. Side, 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 and side, angle, side. Okay, so if it was going to be any of these 3, it would have to be what? Look at the diagram. If it were to be any of those 3, it might be what? Side, angle, side. Because where are the angles that are congruent? The vertical angle. So if they are similar, it might be by side, angle, side. All right, so let's check. The 6 could correspond with, I don't know, let's flip it over, the 9, right? Is that the same as the 8 matching up with the 12? Are those 2 ratios equal to each other? Yes, they are. 72 equals 72. So the sides are in the same ratio. So triangle ABX is similar to triangle, let's see, ABX, CDX. Now, if I ask this tomorrow, using a theorem or postulate, I'm looking for one of the 3 reasons. Some of you guys just said the sides were in the same ratio. That's incorrect. You don't know that CD and AB were in the same ratio because I didn't give you any numbers. Okay? They are similar by side, angle, side similarity. Okay, so when I ask for a postulate or theorem, I'm looking for one of the ways to prove the triangle similar tomorrow. Questions? All right, let's move on. What else is there here? Okay, 4. Even if you got 4 right, pay close attention to this bad boy. All right, I got perpendicular lines. Yep. RT is 6. TP is 4. SR is 5. Find QT. Everybody, you cannot use 6 in your proportion. 6 is not a full side. When you set up your proportion of corresponding sides, they need to be full sides, not partial sides. So you cannot put 6 anywhere in your ratio. All right? X corresponds with what? 5. 4 does not correspond with 6 because 6 is not a full side. It corresponds with 10, PR. Okay? So full sides only, please. Full sides only. Not going to go to 5, but you better believe we're doing 6 and 7 here now. Woo, baby. It'll be there tomorrow, as scary as it may seem. Change things if you need to, please. Change things. MB is x minus 3. MN is x plus 1. BC, x plus 4. And I'm missing one. AM, 4. Not the side splitter. I cannot apply side splitter here. These would need to be over here for side splitter, okay? So here we go. What does that x plus 1 correspond with? X plus 4. The other side in this triangle is 4. And the 4 does not correspond with x minus 3. It corresponds with AB. Now, this kind of drove me nuts. Why are you plugging that into your ratio when you have no idea what to do with it? Can you please simplify that tomorrow before you put it in your ratio? Because I didn't see one person who put it in here who knew what to do with it. All right? Simplify it. What's that simplify down to? X plus 1. There you go. Done. I don't even know how many we've done of these already, especially this week. Guys, are we okay here doing this tomorrow? Yeah. Binomial times a binomial. X squared plus 2x plus 1 equals 4x plus 16. Get one side equal to 0. X squared minus 2x minus 15 equals 0. You can use quadratic formula tomorrow. We ended up factoring this because you can. Two numbers that multiply to 15 but add to negative 2. 5 and 3, minus 5 and positive 3. So you do end up with two answers, 5 and negative 3. But unlike all the review problems I've given you on the back of your assignment sheet, this problem has a diagram. Yep. So watch. Ready? If I take negative 3, it's okay there, right? If I plug in negative 3, that's okay. Not okay. Not okay if I plug in negative 3 here either, because I'm going to get a negative side length. See ya. So it's just 5. Any questions there? All right. And then we got another one. Okay, first thing right off the bat. Everyone ready? Direction before you put any pencil or pen to paper. I automatically know I'm going to need quadratic formula here. Anybody know why? Amy. Says simplest radical form right at the top in the directions in bold. No chance of factoring. You know you're going to have to use quadratic formula here. All right, here we go. These are parallel. Can you apply side splitter here? Yeah. Darn right you can. You don't have to, but you can, so I will. 2 over 2x minus 1, and then 2x minus 1 over 5. When you guys multiplied these two here, I thought I was giving you some type of calculus to do when I asked you to multiply those. 2x times 2x? 4x squared. Yeah, not 4x, everybody. 4x squared. Minus 4x in the middle, and then, this was actually the roughest part to see. Negative 1 times negative 1. Yep, a lot of people left at negative 1. Negative times a negative is a positive. Equal to 10. Move the 10 over. 4x squared minus 4x minus 9. Not 11. Minus 9. Quadratic formula, I'm not going to go through that. I'll just let you know it was 4 plus or minus 4 radical 10. Because you got the square root of 160 underneath it. Okay, let me talk here now, because I think we may still be having issues here. Remember, the 8 belongs to both sides. Everyone ready? 4 over 8 reduces down to what? 1/2 plus or minus other side, 4 over 8 again. So radical 10 over 2. Both have the same. You can keep your answer like that if you want. Both of them have a 2 though, right? In the denominator. So can I write it with just one denominator of 2? But what's provided here? Diagram. You will get a negative side length if you do 1 minus square root of 10 over 2. So I just accepted 1 plus square root of 10 over 2. I cannot accept the negative answer. It gave me a negative side length. Questions, comments, any concerns? All right, so let's let's not make the same mistakes twice. Can you guys go to, I'm not too sure what page just get your packets out. How about that? Let's get your packets out. Looks like you guys are going to page 36 for me, page 36. Okay, good, you do have it. I was worried. Whew, I provide you with a lot of resources here. Textbook questions to try, whole bunch of additional questions. If you look, keep going, I think maybe a page or two past this, you'll see the answer key to the additional questions. And on the very last page, you see the answer key to the textbook questions. Okay, it's all there in the packet, so I'm not going to post anything to Aspen as far as answers go. All right, usually I'd say, all right, go ahead, work with whoever you want. All right, I can't do that today. All right, I'm too nervous about how tomorrow's going to go. Not because it's tough, because we got that huge gap in between the first half and the second half of the unit. All right, so I'm going to do as many of these review questions as possible with you. First one we're going to start with, number 3. Now, it's 4, excuse me, 4. Number 4, about Nate and his dad's sailboat. There's no sailboat. Is that 3? Oh, I didn't put that on there. Never mind. Oh. What? No, that's not the Nate I wanted. I needed a different Nate. All right, let's go 2 then. Let's go 2. Here we go. Let's go number 2. All right. Are the following triangles similar? If they are, write a statement and a theorem or postulate why. Very similar to your quiz. So let's look at 8. All right, you got 3 methods. If it's going to be anything, it's going to be what? Side angle side. We just have to test if those sides are in the same ratio. Anybody got a ratio they want to set up and test? 4 to 10, is that the same ratio as 3 to 7.5? I don't know. Let's figure it out. Are those, again, figuring out if it's the same ratio. You can cross multiply and they come out to be the same values, or just reduce them in your calculator and see if they're the same. And what are you finding? Are they the same ratios? Yes, they are. So I can say yes, triangle ABC, similar to DEC. And again, I don't want to don't tell me the sides are in proportion, because that's not true. I don't know about AB or ED. But what method? Side angle side similarity. And yes, you got to have that tilde there. Guy said tilde. All right, let's go to B. If anything, it's going to be what? Again, whoa, side angles. Where's the angles? Oh, okay. All right, let's test the sides. Anybody want to come up with a ratio to test? 6 over 9, is that the same ratio as 5 over 8? Right? All right, well, is it the same ratio? Is 6 over 9 the same as 5 over 8? No? No. All right, whoa, though. Hold the phone. All you guys did was just flip it over. Couldn't I also match up these vertical angles by rotating it on top? So this is not the only, 6 could not only match up with the 9, it could also match up with what if I rotated it around? The 6 could also match up with, everyone say that, it could also match up with the 8. You need to test both out. One may do it, one may not. And the 5 can match up with the 9. But are they still the same? Are they the same in that case? No, they're not. So I've tested every possibility where these two angles could match up with each other. None worked, so not similar. Yes. One worked or one? Well, then that's the only one I would test. Okay. Do you see why I need both? Because I could go like this for those angles to match up, and that would be this one. Or I could turn it like this, and the angles would match up, but now the 6 and the 8 would match up instead of the 6 and the 9. So I do have to test both in that case. Anything else? All right, let's go to the proof now. Number 4. There's only one on there, but what did I say, a 10-pointer? All right. And this is a good one to review with you because this is about as far as these similarity proofs go. When you look at the proof statement, what's going through your mind as far as the last reason? The last reason. What's going to be the reason that this is going to be true? We did this on Monday. Product of the means equals product of the extremes. Will CSSTB be involved, Will? Yes, it will. Yes. But not at the end. Okay, it's going to be product of the means equals part of the extremes. Even before we do any of that, we got to prove triangles similar. Woo, almost did it. Prove triangles similar. Ooh, I see a couple triangles there. I don't just see two. I see multiple, more than two. So can you help me figure out which two here? And if you're wondering, yes, AFB is a straight line. For us, anyway. Okay, how do I determine? What's the first segment listed in the proof statement? AB. Can you find one and only one triangle where AB is a full side? All right. So we know it's this big dog here. What's the next segment that's listed? DE. Can you find one and only one triangle where DE is a full side? Yep, triangle DE See? So it looks like we have both triangles now. What's the only method in a proof we use to prove triangles similar? Angle, angle. So I need, I'm afraid to go to the number generator because it's going to lose my recording. So I'm just going to ask you guys. Anybody see a pair of angles up there that I can prove congruent? Justin? B and D, yep. Why do you say that, young Justin? Oh, watch your mouth. No. He's rattled. Thank you. You got it. There's one pair. Oh, Will. Okay. That is a true fact.
I'm just trying to get alternate interior angles. You can do it either way.
Okay, let me put that down. Why is that true, Will? Okay, now where are your alternate interior angles then? Okay, ready? You said these two, right? Ready? What lines do I need parallel then? Okay, so stick with your parallel lines. There you go. Those two right there. So angle BCE congruent to angle CED. Parallel lines imply, what type were they, Will? If you didn't notice, some people were yelling at Will for doing the other set of parallel lines because they knew if you said these two were parallel and you wanted to get those alternate interior, you would have to add an extra step and say what? The extensions are parallel. Okay, so that would have been an extra step. All right, now I have two pairs of angles, so I know triangle. What triangle are we on here? ABC? Yep. Triangle ABC. Make sure you write the similar sign. Similar to, let's see if I go ABC, ABC. I got to go CDE. CDE by angle, angle. All right, now here's where the fun begins. What's next? Because the triangle's congruent doesn't mean the means and extremes are equal. There's a step in between there, Emma. Your sides are in proportion, and be careful how you write that. I had no idea what you said, but I'll listen one more time. What was this one? I have no idea if that's right, but I'm going to check if it's right. How am I going to check? I should be multiplying AB and DE, right? If I look at Emma's AB and DE, AB and DE when I cross multiply, okay? Your means and extremes should be diagonal each other. And this is CSSTP. If you plan on using it, please get it in the correct order. Corresponding sides of similar triangles are proportional. Then I can say the product of the means and extremes are equal. AB times DE equals CD times BC. Product of the means equals product of the extremes. All right. Guys, there's plenty of resources there, especially factoring and quadratic formula for you. Good luck to you tomorrow. I'll be here after school if you want to sit down and review anything. All right, you've got a lot of questions if you need to practice.